Hello students. So today we will be continuing our discussion on the ecosystem theories and also the integration in the urban level with case studies. So first we will go for the recap on this urban integration of ecosystem theories, and then we will be bringing 4 different case studies from all over the world, and we will see that how different necessities has driven them to take different type of strategies and decisions, and in each case we will connect them with urban ecosystem theories. If we remember our the second module as well as the previous module where we have discussed the ecosystem theories, we talked about these 5 levels of ecosystem theories: foundational level, basic theories; intermediate complexities, dynamic behavior and change; systems level theories, emergent properties and feedback; advanced theories where we discuss resilience, complexity and global changes. And the last one is not a theory, it's a integrative frameworks. So quickly let us go through this each one of these levels. Foundational one where we discussed energy flow theory which frames urban metabolism. Linzmann concept that structures the urban traffic and resource cycles, and as we discussed, law of the minimum that identifies critical limiting variables for sustainability and resilience. In the intermediate complexity, we discuss succession theory, which guides temporal evolution and regeneration; carrying capacity, which defines the sustainability limits and the thresholds for growth; intermediate disturbance hypothesis, this helps us in optimizing resilience through controlled variability. Next level we discuss, that is the systems level theories. And in this theory, we talked about the feedback and the controls. Homeostasis theory maintains the stability through feedback and resilience under stress. And the thermodynamics, which in the last class only we discussed in details for the urban context, that is the max power principle that governs energy optimization and systemic evolution. Now let us see the fourth level, that's the advanced theories, where we discuss the resilience theory, which helps us in understanding the absorb and reorganize, absorptions and reorganization of different activities. Panaki theory evolved through cross-scale feedbacks, and alternative stable states theory is very much important when the system face potential regime shifts. Ecosystem services theory relies on ecosystem derived benefits. And the last level, that is the integrative frameworks, here we brought that particular context where urban ecosystem, which is completely having a very strong role of human society and obviously the ecology, there we have tried to understand what are the different frameworks are existing. So first one we discussed that socio-ecological systems framework, which unites human nature co-adaptation; meta-community and landscape ecology, which explains the spatial on space, how the ecological patch matrix they are connected. And the last one we discussed, critical transition theory, which identifies thresholds and transformation pathways. So this is the basket today for discussing the case studies. And this is going to give you a very comprehensive understanding that these 4 case studies, which are coming from Brazil, Netherlands, USA and India, integrated theories for each one of them we can discuss, like curative succession, energy flow, carrying capacity, and the primary catalyst is a proactive vision. For Rotterdam, resilience theory, critical transitions, alternative stable state and panarchy, and reactive crisis, that is the primary catalyst. For Los Angeles, succession, carrying capacity, socio-ecological system framework are the most relevant theories to be discussed. and it is anticipatory crisis group as the primary catalyst. For Bengaluru, India, that is the socio-ecological system framework, landscape ecology and resilience. And the primary catalyst is the bottom-up stewardship. And key constraint, if you have looked at, you can see it's water only, but many dimensions of this water. First one is the supply side, second one is the excess water, third one is the scarcity of water, and the fourth one is also deficit. So let us go to each one of these problem or case studies one by one. What happened to Curitiba? Curitiba was having a problem because it's a urban sprawl, lot of population rise without the population growth without control, and definitely the water was not being managed properly. So there was several managerial crisis in this particular city. So if we try to look at their focus, they try to solve this particular problem from the perspective of the long term multi decade urban transformation. And from the sprawl, they would like to go for a planned living system. So that was the focus. The theories, as I already mentioned, succession, carrying capacity, energy flow, ecosystem services are the most relevant theories. The city was planned as an interconnected organism, not a machine. So that's the primary shift or vision for this particular city. As I already mentioned, the city was facing the problem of rapid urban sprawl, flood risk, waste management, and uncontrolled population growth. So, let us now look at this particular case from the theoretical perspective. Succession theory matured green spaces from pioneer to late successional, and 85% almost are the non pioneer species. Ecosystem services linked green space to population. Square meter area per person, it improved like anything. Parks double as floodplains. So all those initial problems identified were tried to be resolved. A 2023 study found that the urban parks function as a biodiversity refuge, with 85% of the trees being non pioneer mature species. So that's a shift. Energy flow theory, phase one, it actually had attention on the BRT system for efficiency. It's a transportation model which they actually utilized. And in the phase two, solar pyramid for circularity in the energy system. Carrying capacity, managed water as the primary limiting factor. So, water became the main factor which is limiting the growth. How the improvement has been measured? Green space, as I mentioned, it has improved from 52 to 64.5 meter square per inhabitant, whereas WHO only recommends 12 square meter per person. So, what a good achievement. In the energy side also we can see that bus rapid transit system had brought 50% energy reduction, and this 8 megawatt solar energy is getting produced through this solar pyramid. That's the phase 2, and this solar energy is actually offsetting 90,000 tons of CO2. That is again a very good achievement. In the water side, the system wide deficit, the supply side is 6,950 liter per second versus the demand is 7,000 liter per second. So, almost that gap has been breached. So, we can see that it's a very good initiative with good success which can be measured as well. So, key takeaways from this case will be Curitiba's entire plan is constrained by its primary limiting factor, that's the water. Carrying capacity, we were discussing, it was based on water. The city has no resilience to drought. Its famous green initiatives like parks that double as floodplains were not amenities. These green initiatives, these parks were not amenities. They were critical survival mechanism for water management. So they are the infrastructure which is required. Curitiba's green space metric is not a static percentage. Solar pyramid generates 30% of energy for public buildings. A surface metro, which I was discussing at the phase 1 that initiative was taken, that's the bus rapid system, that achieved a 50% reduction in energy consumption versus conventional buses. And this represents a late successional strategy. With this, we come to the second case example, Rotterdam, Netherlands. In this particular case, Rotterdam, as you know, probably, its mean sea level is very low, so it is always challenged with the problem of seawater intrusion. But what we could see that with ages, if we try to see from the 1400 century, we could see this particular port city has gradually captured the sea area that they converted into port area. So that's a continuous extension which we can see. In this image also you can see at during the time frame of 1400 to 1800, this city was only here, but then gradually the city continuously extended 1920 to 1940. Then we could see by 1960 to 70 all these areas got actually converted. It was created as land, and this reclaimed lands acted as a port. And now in 2013 to 2033 we can see this is the extended part. So continuously in each and every decades they have a plan, and every time they are increasing in speed, in extension, increase in area or size, every time it is a larger one, and increase in depth, so that it is also helping them in navigation as a port. So Rotterdam as a port continuously getting better and better success, and at the same time they were really trying to look at the how to really fight that water, because the mean sea level is very low. So, and they had traditionally worked for that only. But then very recently there was a flood, and that flood we will now discuss how that changed the perspective and the narrative of this Rotterdam's development. So the focus became after this flood a fundamental regime shift from fighting water to living with water. The theories we can discuss with this particular case are the critical transitions, alternative stable states, resilience theory, and panarchy theory. The concept is moving from a rigid resistance based system to a flexible adaptive one. So, what is that rigid resistance based system? That is fighting water. And what is the flexi one? That is living with water. So, that's a great shift in the paradigm. The urban challenges, catastrophic flood risk from both sea level rise as well as the river floods, that is always existing. So, how to really take care of it, how to build the resilience against it. Rigid, aging command and control infrastructure, we will see that how they become a brittle system. When that flood came, they have not been able to take care of the scenario as it was expected. So, as I mentioned, the theory application, critical transition, alternative stable state, resilience theory, and the panarchy theory. On the right hand side, if you see, you will find that the attitude in after this regime shift is not entirely the engineering one. Here we will find that how the ecological perspective also crept in the strategies. Why it is critical transition theory? I am saying because 1995 Rhine floods acted as tipping point that broke the old regime of fighting the water, because that didn't help them. They had worked on that, they had everything on plate, but then also that flood was devastating for the city. Alternative stable states are managed shift from basin 1, which is command and control, to basin 3, the circular resilience. We will be discussing this one. It's a very interesting theory. It is also actually connected with the resilience theory. And in the resilience theory, we will see that how they shifted from the engineering resilience, that resistance, to adaptation, to ecological resilience. You can see the example here only. And the Panarchy theory we will discuss in detail, that is the adaptive cycle that was used to model the policy shift from collapse to reorganization. So, the first one, the theory one, a critical transition, and we will find a very interesting thing here, that it is actually taking care of the resilience as well as alternative stable theories as well. Rotterdam's history shows a flip between three basins of attraction. This basins of attraction is actually uh, we can first try to understand what this particular concept talks about, these basins of attractions. Basins of attraction means let's imagine that we have a valley and we have a ball here. So if until and unless there is a strong push or shock, then if it is having a high resilience context, the ball will be within the, it's a very small movement it will have, because the shocks are not being able to destabilize it. But if the resilience is low, even a medium shock can actually push this ball to a next regime. Recovery rate for a high resilience scenario, in that basin it will be easily, it can come back and it can go for that stable state. But recovery rate when the scenario is low resilience, there it can actually take time to come back to that particular stable state. And what is the second basin? Second basin is if this threshold point is being tipped, then the regime shift, which I was discussing here, for that in a high resilience system, you need a very, very great shock, great changes. Shock can be the flooding, shock can be the governance destabilization, anything. But if it is a low resilience, that regime shift is quite possible easily. So, this is the fundamentals behind this basins of attraction. And this particular theory also pertains under the resilience theory. But we would like to see this basin theory, the three basins here, three basins of attraction. The first basin, till that 95, the command and control. It was a very strict rules and regulations. Whatever is being constructed, everything is taking care of the code, code provisions. Rigid state defined by dikes and barriers, all engineering controls to fight water. And it was actually been proven to be in the low resilience regime. Once that 95, that flooding event happened in the Rhine River. So the second one, this is the tipping point, this is the second basin, that is the tipping point, 95. Rhine River floods, a near catastrophe that broke the stability of the old regime. So that engineering infrastructure, the resilience system could not take it. So what happened? The entire city actually experienced havoc, damages, and that experience taught them that their next basins of attraction has to be different. And the basin 3, after 2015, So it took 20 years to come out with a different vision, strategic decisions, that is the circular resilience, the new resilient state, that is living with water, adaptation, not to fight with it. So here ecological concepts help them a lot. And the other one, as I said, the adaptive cycle, we can also look at this particular decisions uh, from the basin 1 to basin 3 through this adaptive cycle as well. First is the exploitation. It's not actually, if we try to discuss it according to the time scale, probably it will not fit into this theory that easily. So, we have to go by the theoretical perspective like exploitation. Post 95, that post flood, the shock exposed limits of rigid control systems. Till that time, everything was going fine. People were quite confident. But initial adaptive experiments began, that exploitation of knowledge came in. That is room for the river, water plazas, pilot projects. So many things started after the 1995. Conservation, pre 1995, the city's flood protection infrastructure was highly efficient, but it was proven brittle and rigid. This flood control infrastructure, the dikes and the barriers which we were discussing. So that's the conservation. So this conservation till 95 was going okay. Then the release, 95 floods. Systemic rigidity breaks down. Infrastructure and policy paradigms release control and triggers openness to change. Though it took time, as I was referring to, so reorganization took lot of times. So this 95 to 2015, living with water, Rotterdam climate proof, and many participatory design ethos form. Those came in. So we can discuss the Rotterdam case with the adaptive cycle as well, in addition to the basins. So how to really measure these achievements? Infrastructure, 40 plus kilometer of green streets, 150 pockets park, 150 plus pocket parks, and 2.5 square kilometer restored wetland. Just imagine the achievements. The biodiversity, it was having around 12 species. Now the aquatic species richness increased 130% to 28 species. But there are some nuances as well. Aquatic insects abundance declined 53% as well due to pollution. That has been also measured. Next case study is the Los Angeles urban forest. This is also having a very important social story to talk about. More we go into the story, you will get to know. Proactive managed ecological succession to build climate resilience under severe constraints. That is the focus of this urban forest in Los Angeles, 2006 onwards. The theories we can link with this particular effort is the succession, resilience, carrying capacity, ecosystem services. The concept is a preemptive response to a future climate crisis in 2050 onwards. What are the urban challenges it has been able to look at that it can resolve? Extreme heat conditions, severe water scarcity, future climate change, which has been mentioned now, drought and heat, both. Profound social and environmental inequity. This is very important to take a note on. Actually, more we go into this, I will be discussing initially that social and environmental inequity, and then we can see the significance of this particular type of initiatives. An aerial view of the Harbor 110 freeway and dense communities in south central Los Angeles shows a lack of foliage. We can easily, later on we will show how it is linked with this inequity. It's a special area It's a particular area where this particular problem is there. Enter Los Angeles is not like this barren. You can see here in the Beverly Hills, it's a contrast starkly with the previous one, where you can see lot of greens. The theories which are applied in this particular case, we can link easily, that is succession theory, a human guided succession to manage species turnover and plant climate adapted species. Carrying capacity, a wicked problem, balancing thermal capacity, which needs the trees, versus the water capacity, which cannot support trees because water is scarce. Ecosystem services, trees are used as critical public health infrastructure, again, not amenities, for cooling and air quality improvement. Socio-ecological framework, system framework, using tree planting as reparative justice to reverse historical redlining policies. This is something we will be discussing. Reparative, to repair what injustice has been done to particular communities, to reverse that. You can see these red lines, these red dots, especially in the 30s and the 40s. These are the earmarked areas by the local government, that these are the areas where black people, the minorities and the black people are staying. So the way these particular spaces, that those areas were serviced and attention was given, very small plots, no scope for proper pavement and all this. So you can see these red dots, it's a official red lines which has identified and demarcated these areas from the rest of the things. So examples of GIS data on tree locations from the 1920s, 30s, 40s and 2006, overlaid on vertical digital aerial photography in the San Fernando Valley. So this red lines is a very depressive, oppressive, I will say, oppressive scenario which it is communicating. In every pocket of the cities, probably this type of areas lies. Even in India, we can really have a special attention to them. So the canopy targets, realistic was 35 to 40% ecological carrying capacity versus the aspirational 50%, because it's a water need vis-a-vis available water. Health, 25 to 30% reduction in heat related mortality, that is the target. Temperature, 2.5 to 3.5 degrees Celsius reduction. And the equity, prioritization maps correlating low canopy with redlined areas. So, the key takeaways from these particular cases, the urban forest is treated as critical urban health infrastructure. Ecosystem service goals, a 2022 study found this could save roughly 1 in 4 lives currently lost during heat waves. The key driver is the social equity planting that is prioritized in low canopy, low income, high minority neighborhoods which were redlined. The plan uses ecosystem services as a tool for reparative justice. So, what inequity has been there, is there till now, that has been tried to be addressed through this particular plan, urban forest. Formerly redlined neighborhoods today have 2 to 3 times less tree cover. Today also, they are on average 2.6 degrees Celsius hotter than the non-redlined areas. So the gap was so wide that even this urban forest initiative is closing that gap but could not really reach that target of equity. The urban forest strategy is not an environmental policy here. It is a public health intervention as an act of reparative justice. Utilizing ecosystem services such as cooling, pollution control to address a life threatening historical, social, and environmental inequity. So, this is a very, very glaring example that what happens in the urban ecosystem, this inequity, which we have also talked beforehand. So, and I'm not saying it is only existing in Los Angeles. Again and again, I'm saying you as a future citizen need to really look at what is happening in India also. The last example is from Bangalore Lakes from India. The focus is a bottom up socio-ecological system revival in a city that has catastrophically overshot its carrying capacity. Any measure you take, it has overshot. The theories we'll be discussing: SES framework, landscape ecology, succession, and resilience. The concept is community stewardship reactivated in a collapsed, fragmented governance system. As the governance, local governance could not really resolve the issues, so community came with their own initiatives. The urban challenges, which it is resolving: catastrophic water deficit, overshot the carrying capacity, collapsed or fragmented governance, and loss of lake network, city of thousand lakes. And now you go and you just try to find how many lakes are there. So the theory application: the socio-ecological system framework, diagonizing the failed system, fragmented governance, and the restored system, the community stewardship loop. Succession theory, we can find the application in the managed pioneering clearance of the sewage to the mid-successional floating wetlands, native plants. Landscape ecology, restoring not just patches, that is the lakes, but also trying to take care of the network, the connectivity. Carrying capacity, lake restoration as a survival strategy to recharge the groundwater. You can see how the community is actually in action. Now let us see. It's a very, very strong statement you can find in this particular figures here. In 2010 and in 2018, within 8 years, you can bring it back. You can bring the life back to the lake. So, how you can measure the success? Water deficiency, 2632 MLD is the demand side, whereas the supply side is only 1460 MLD piped one. So, what is happening to the rest? And who is actually bearing the brunt of it? Definitely the vulnerable community. The connectivity index baseline of 0.42 to target 0.70 plus. Biodiversity, bird species from 3 to 35. So it's a quite good achievement. Water quality, it has been measured through the chlorophyll, which was 45 milligram per liter. Now it has come down to 18 milligram per liter. So such a healthy one right now. Less demand for the oxygen. So key takeaways from this particular case is the intervention. Community stewardship, like this Puttenhalli Lake 17, which created a positive socio-ecological feedback loop. Ecological improvement happened, so community got engaged. Formal stewardship came from the community, and further ecological improvement is happening. There's a continuous loop going on. But there is also the other side of this change, the restoration paradox. This also brought a negative feedback loop. Restoration happened, which derived the rising property values, and gentrification happened because the local people could not really afford to be there, whereas the other people who migrated from other states and having good, or maybe even from other countries, they are being able to afford these particular properties. So what is happening as a result? Displacement of original livelihood users, Laws of the Diverse Stewardship Foundation. So that's the way we can see that there are plus and the minus in probably all these initiatives if we try to look at. So key takeaways, the restoration is not just about patches, single legs, but about the network. That's very important because we are talking about blue-green infrastructure, not amenities. Microscale succession, invasive removal, native planting, and floating wetlands to treat sewage. I also shared the images with you. At the macro scale, the landscape ecology, restoring the cascading system. The proof is bird species are back from 3 to 35. So it is proving that the connected landscape is working. The lake restoration is not an environmental amenity, it is an urgent survival strategy like the previous two cases as well to restore the landscape's ability to capture monsoon rain and recharge the groundwater. So, with this, we complete today's class where we discuss the theories and the case examples and their integration. These are the references. Thank you.